All right, let's dive right in. Have you ever wondered what makes music, music? Today, we're going to pull back the curtain and look at the absolute fundamentals: pitch, notes, and octaves. This is where it all begins. Okay, so let's start with a question that, believe it or not, you already know the answer to, even if you don't know why you know it. We can all instantly tell the difference between a high-pitched sound and a low-pitched sound, right? But what's actually happening there? Well, it all starts with our first big idea: pitch. You can think of pitch as the most basic building block for everything we're about to explore. It's the language we use to describe what a sound feels like. So let's get a really clear definition down. Pitch isn't some complicated, scary theory. Nope. It's simply the word we use for that gut feeling you get when you hear a sound. Is the sound high or is it low? That's it. And we are surrounded by examples of this all day, every day. A high pitch kind of feels thin and sharp, like a flute. A low pitch feels deep, heavy, like a big old bass guitar. You already get this stuff instinctively. So what's the science behind that feeling? What's the secret? It's actually super simple. It's all about vibration. When you hear a high note, it's because something is vibrating really, really fast. And a low note? Well, that comes from something vibrating much more slowly. That is the entire secret right there. And, this isn't just a Western thing. It's a totally universal human concept. If you look at Indian classical music, for instance, they have Thar Saptak for high pitch and Mandra Saptak for low pitch. Different words, but the exact same fundamental idea of organizing sound. Okay, so we get the difference between high and low, but how do we talk about specific sounds? How do musicians actually communicate with each other? Let's move on and see how this feeling of pitch builds into a real system. And the solution to that problem is the musical note. Just think of it like putting a label on a very specific vibration. We've all just kind of agreed that a certain pitch gets a fixed name, and that lets us talk about it and, write it down. And this is exactly why it's so incredibly useful. I mean, can you imagine trying to write a song by describing every single sound? Okay, now play that sound that's just a little bit higher than the last one. It would be impossible. Instead, we just say, play G, and musicians all over the world know exactly what pitch we're talking about. So, how many of these core named pitches do we have to build from? Well, at its absolute core, most of the music we listen to is built on this magic number, 7. And here they are: A, B, C, D, E, F, and G. These are what we call the 7 natural notes, and they basically form the alphabet of Western music. Seriously, just like letters form words, these notes are used to build the melodies and harmonies you hear every single day. But why these 7? It's a really cool mix of physics and biology, actually. The vibrations of these 7 notes have very simple mathematical relationships with each other. And it turns out our brains are just hardwired to hear those simple ratios as sounding pleasant, stable, correct. All right, pay attention here, because this next concept is probably the most important one in this whole explainer. Let's talk about the octave. I like to think of it as music's magical echo, and it is the key to how music is structured. So the technical definition is that an octave is the distance from one note to the very next note that shares its name. And this happens when the frequency of the vibration exactly doubles. But here's the really wild part: the psychological effect. When you hear a note and then it's octave, your brain doesn't really hear it as a totally brand new sound. Instead, it hears the same note, the same identity, just at a higher level. It's like a perfect sonic copy, just shifted up. And this is how it all clicks together. That 7-note pattern, A through G, it doesn't just happen once. It repeats over and over again, climbing higher and higher in pitch. And every time you get back to A, you've just started a new octave. So we've got pitch, we've got notes, and we've got these repeating octaves. Let's put it all together and see what this system actually looks like on an instrument we all recognize: the piano keyboard. The keyboard is just a perfect visual map for all this theory. The white keys, those are our 7 natural notes. And you can see it so clearly, right? The pattern of white and black keys just repeats itself again and again all the way up the keyboard. And every single time that pattern restarts, you've just entered a new octave. So let's think about a few real-world examples. When you play the same note but higher on a piano, you're literally moving up an octave. When you tighten a guitar string, what happens? You make it vibrate faster, which raises the pitch. And if you loosen it, the pitch gets lower. See? It all comes back to the speed of that vibration. Now, this is a super important point, so I really want you to remember this.
Pitch is not the same thing as volume. They're two totally separate qualities of a sound. A giant foghorn can be incredibly loud but have a very, very low pitch, and a tiny little pin drop can be super quiet but high-pitched. Don't mix them up.
Okay, so let's lock in what we've learned today. Here are the key takeaways. 1. Pitch is just how high or low a sound feels to your ear. Simple. 2. A note is nothing more than a pitch that we've all agreed to give a specific name. 3. There are 7 of these natural notes, A through G. And 4. An octave is that magical echo, the same note just repeated higher or lower.
So, that's the foundation. But I know what you're thinking. If you've ever really looked at a piano keyboard, you know there are also black keys, right? We've just explained the 7 natural notes. Those are the white keys. But what about those 5 extra notes tucked in between them? What's their story? Well, that is a question for our next explainer.